Determine whether the lines are parallel, perpendicular, or neither. In this first example, we have a couple of lines given. Whoops. Let me get that fixed real quick. Sorry, y'all. We have two lines given. We have y equals 3x minus 4, and we have the other line y equals 3x plus 1. Now, these are both in slope-intercept form. Our first line has a y-intercept at -4 and a slope of 3, so it will have a rise-to-run ratio of 3 to 1. That's our first line. Our second line has a y-intercept at +1, and it has the same slope, 3 to 1. Because these two lines have different y-intercepts and the same slope, they're considered parallel lines. They will run beside each other forever and never touch. In our second example, we have the line y equals 3x minus 4, which we looked at above, and our second line is y equals -1/3 x plus 1. Our first line stays the same. We have a y-intercept at -4, a rise-to-run ratio of 3 to 1, and so this is our first line. Our second line has a y-intercept at +1, but because its slope is -1/3, it will have a fall 1, run 3 ratio. So this is our second line graph. These two lines intersect at a 90-degree angle. The product of your slope is -1. In this third example, we have the lines y equals 2x minus 4 and y equals -2x plus 1. Graphing our first line, we have a y-intercept at -4, a slope of +2. That's a rise 2, run 1 ratio. So here's the graph of our first line. Our second line has a y-intercept at +1 and a slope of -2. So we plot the y-intercept. A slope of -2 has a fall 2, run 1 ratio. This is the graph of our second line. These two lines intersect, but not at a 90-degree angle. This is a case of neither parallel nor perpendicular. Parallel fails immediately because our slopes are different. Perpendicular fails because the product of our slopes is not -1. Looking at our fourth example, we have the special cases where we have a horizontal line and a vertical line. Line 1, y equals 4, that's a horizontal line. Any point that falls on this line will have a y coordinate of 4. Our second line is a vertical line, and it will pass through all points with x coordinates of -5. These are perpendiculars. Find equations of the lines that pass through the given point and are parallel and perpendicular to the given line. The line we're given is x plus y equals 5. The point we're given is the ordered pair 2, 1. X plus y equals 5, if you modify, can be written as y equals -x plus 5. That's a slope of -1 and a y-intercept at 5. This gray line is the line given. That's x plus y equals 5. The point we're given is 2, 1, and that's where this black dot is located. We need to be parallel to the gray line, so we have to use the same slope. That tells us for our parallel line, our slope also must be -1. If you put a line through this point with a slope of -1, you will find that it'll cross the y-axis at +3. So that tells us our y-intercept is 0, 3. We can write the equation of that line, y equals mx plus b. That's y equals -1x plus 3. Now, a line that goes through the point 2, 1 that's perpendicular to the gray line would be this blue line. -1 times +1 is equal to -1. So our perpendicular line has to have a slope of +1. Remember, perpendicular lines, the slopes will have a product of -1. So our perpendicular line has to have a slope of +1. If we draw a line through the point 2, 1 that has a slope of +1, that's rise 1, run 1, we will find that we have a line that crosses the y-axis at -1. So we can write the y-intercept as 0, -1. Now we can name the line. That's y equals 1x minus 1, and that's the name of this blue line. This red line goes through the point 2, 1, and it's parallel to the gray line. The blue line goes through the point 2, 1, and it's perpendicular to the gray line. There's a 90-degree angle. Next example, we're going to do the same thing. We're given a line 2x plus 3y equals 6 and the point -5, 2. This equation that's given, if we subtract 2 x's from both sides, we get 3y equals -2x plus 6. Dividing all the way through by 3, that gives us y equals -2/3 x plus 2. Our slope is -2/3. Our y-intercept is +2. So sketching the graph of this line that's given, we have this gray line, y-intercept at 2, and a slope of fall 2, run 3. So this is the line given. The point we're given is -5, 2, and that's over here in quadrant 2, -5, 2. Our parallel line has to have the same slope of -2/3. If we start at this point, -5, 2, and we use a slope of -2/3, we will find that the y-intercept occurs somewhere between -1 and -2. It doesn't occur at an exact location, so we can be clever and set up our equation y equals mx plus b. We know our slope has to be -2/3, that's our m. The point we're supposed to go through is -5, 2, so y is 2, x is -5. Multiplying, that's +10/3. Solving for b, 2 minus 10/3. 6/3 is equal to 2. I just wrote it with a fraction so that I'd have matching denominators. 6 minus 10, that's -4/3. That's our y-intercept. -4/3 is just a little bit below -1. It's -1 1/3. We can still write the equation of our line. This red line has the equation y equals -2/3 x minus 4/3. In order to get a perpendicular line, we have to figure out what would we multiply -2/3 by in order to get an answer of -1. Visually, it's easier to just flip our fraction and change the sign. If you take -2/3 and you multiply by 3/2, your answer will be -1. So our perpendicular line must have a slope of +3/2. Starting at this point, if we go up 3 over 2, up 3 over 2, and repeat, we'll see that our line crosses somewhere between 9 and 10. We don't know exactly where, but we do know it's between 9 and 10. Similar to what we did in the red ink, in the blue ink, we have y equals mx plus b. Remember, the point given is your x and y value. So y is 2, x is -5. The slope we have to use in order to be perpendicular is +3/2. 3/2 times -5 is -15/2. If you add 15/2 to both sides, 2 can be written as 4/2, so that gives us 19/2, and that's our y-intercept. 0, and 19 halves. 19 halves is 9.5, and that makes sense. So our red line is parallel to the gray line, and our blue line is perpendicular to the gray line. Both of these pass through -5, 2. Okay, so we're to our last couple of examples. These are the special cases that we see every once in a while that occur. We have the line given y equals 6, and we have the point -5, 2 given. The gray line y equals 6, that's a horizontal line such that all y coordinates are 6. No matter where you are on the gray line, the y coordinate will be 6. In order to be parallel, we create another horizontal line. If it's got to go through the point -5, 2, then it's going to hit the y-axis at 2. So the name of that parallel line would be y equals 2. Perpendicular, we have to cross the gray line at a 90-degree angle. That forces us to be vertical. If we've got to go through the point -5, 2, a vertical line will contain all points with an x coordinate of -5. So the name of it is x equals -5. And finally, we have another line given. This time we have a vertical line, x equals 6. That's over here in gray. Vertical line will pass through all points such that the x coordinate is 6. If we're going to be parallel to that and go through the point -5, 2, we have to have another vertical line going through the point -5, 2 would be a vertical line that contains only x values of -5. To be perpendicular, we create a horizontal line that's in blue. If it's going through the point -5, 2, then it has to contain all y coordinates of +2. And so that's our blue line. The red line is parallel to the gray line, and the blue line is perpendicular to the gray line.